going to graph these in Desmos using what we know with the words. So a first degree polynomial whose graph intersects the vertical axis at 8. So we're going to put these in folders. And we're just going to name the folders with the characteristics that are being asked of us. So grab a first degree polynomial whose graph intersects vertical axis 8. So literally select, copy, go to Desmos, open up a folder, and paste in the name. And then we shall talk. So what we're going to talk about is how to show a first degree polynomial. So I'm going to do some stuff up here on the computer and some stuff over on the board. I'm doing stuff on the computer so people can see it later if they need to. So I'm going to make a blank Cami doc. Oh, I should have just done that one. Okay. And new blank. So I'm going to make a text box here and call this degree. And then I'm going to hit a tab a couple times. And I'm going to write an equation that goes with that degree. And I'm going to put stuff up here too, so you'll be able to see it the whole period. And tab a couple times. And I'm going to make a rough sketch of the graph on here as well. All right. So our simplest degree is 0. So a 0 degree, I want you to look at your choices and see if you can figure out, of all of those, there is only one of them that has a 0 degree. So take a moment and see if you can figure that out. Here, as I'm going to define the terms on the next page. So if you don't have a second page, add one. And this is going to be kind of where I put the glossary terms. So make a text box and call it degree. Let's see. Oh, I had it up here. It's gone. All right. So the degree, and this isn't the formal definition, but it's going to be pretty good as far as you guys are concerned. So our degree is the highest exponent attached to a variable. And let's see if I can type correctly. Attached to a variable, and a polynomial. Okay. So coming back, if I have a degree of 0, which one doesn't have the variable? Oh, it went all the way down there. Pooh. We'll just move this down. So one more time. Y equals negative 15. I'm going to make a simpler one up here. But you can, if you use negative 15, that's fine. And the reason I'm going to make a simpler one because I want to have a representation of the graph. So y, oh, that is teeny tiny. Oh, it's so small. Okay, so how about y equals, I don't know, 3. So I'm going to make a super rough sketch here. So y equals 3 is right around here. All right. So if I have degree 1, that means I have a variable, but really, do I have an exponent? Nope, because when we have an exponent that has degree 1, we don't actually show it. I have degree 1. Tap, 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 tap. The easiest one to look at there, the easiest one you guys have is what? 4x minus 15. I'm going to make it even simpler than that. Y equals x. And let's pick a different color for my drawing. Let's go blue. So here is y equals x. Wow, that's not good. That's a little better. So y equals x. That's degree 1. So let's pause for a minute and go back to the Desmos. And we want polynomial degree 1. I don't want you to say it. Just see if you can figure out if you can make it. So in Desmos, so stay within the folder, I want to graph polynomial degree 1 that passes or intercepts the vertical axis at 8. Take a minute, see if you can figure that out. So one more time. Your slope could be anything you like. Most people just did y equals x plus 8. Because I can't see it, so what do? Little pinch. Okay. So it has to have a plus 8 in there because you're being informed that it should be passing the vertical axis at 8. It is implied that it's positive 8. Okay, but does that have to be just 1x? No, it could be 2x. It could be negative 2. It could be, I don't know, negative 2/3. Okay? As long as it crosses at 8, they're all satisfying that equation. Okay? So I come back here. That's a first degree polynomial. What comes after 1? 2. So let's see. E. Down. There we go. 2. That's good. So polynomial degree 2. Let's see. We have y equals 3. We have y equals x. Any ideas what the next one will be? Okay, so if you're doing this in Cami, you're going to want to go to the equation editor. Y equals x squared. So it shows up first. Okay. And this is the parent function, so it's just a parabola.
Yes, that's a U.
Kind of looks like a U. Hold on to that thought because we're going to need that later. Okay. So now we're going back to the lesson, and it says, all right, second degree polynomial that only has positive y values. So we're going to grab that. We're going to copy. We're going to go back into Desmos. We're going to close up our old folder. We don't want to see more than one graph at a time, so I'm going to turn it off, make a new folder, paste, and then you take a few minutes. And when we moved it over, I forgot the y. Yeah, because it's an image. So y values. And then you take a few minutes and find a second degree polynomial that only has positive y values. I start with my parent function, which is y equals x squared. Make sure you move these out of the way so everybody can see them. We're going to continue to refer to them. All right, so come down here. I can just start with y equals x squared. I mean, you can put anything you want in front of the x squared as long as it's not y. Somebody said it. Is that it? Negative. Because if I put a negative in here, yeah, then they're all going to be negative. Okay, so let's not do that. So just leave it alone. All I need to do one itty bitty thing. Plus 1, plus 2, plus anything. Damien, tell them what you put in. 0.1. Because 0.1 is positive, and if I zoom out, yep, that's positive. So anything you want. You could put in 0.001. That's positive. I'm going to stick with plus 1. Okay. All right. Done. Questions? All the y values are positive. Doesn't cross the x-axis. Okay. Close. Save. New folder. Close. Save. Turn this one off. Make a new folder. Go back to GeoGebra. Scroll down a little bit. Second degree polynomial whose graph contains the point 0, -9. Again, that 0, -9 is an image, so you're going to have to retype that part. See how it doesn't even include it? So copy, paste, put in 0, -9. Okay. Take a moment. That one. Hey, Geraldine, what you got?
I got y equals x squared plus -9.
Okay, so plus -9 works. Can I just put in -9? Yeah, either one's fine. Okay. And just to confirm, there I'm at 0, -9. So when you actually answer the question, confirm that you're answering the question correctly. So both this one and the 1, 2 above it, they're really saying what? What word could we use instead of the point 0, -9 and the vertical axis at 8? Looking for a phrase or a word.
Vertex.
Vertex. In this case, this one happens to be the vertex. They both happen to be the vertex. Y-intercept. Okay? So if you're not completely familiar with that one, and you might want to write that down for the y-intercept is where it crosses the y-axis. All right. Third degree polynomial. So let's go back here and talk about the third degree first. If you'll pardon the pun. Third degree first. Get it? All right. Here until 2:15. Okay. Here we go. Tab 3. Okay. Y equals 3. And really, what's next to the 3? If my exponent is 0. On that top one. What's really next to x to the 3? I got an x to the
First power.
not first power to the 0 power. But anything to the 0 power is 1, so we don't bother putting it in. Okay? So it's good to know that 0 power really means, and really specifically, what type of graph will you always get then? All lines are straight every time. Not a color. What kind of line is this line?
A horizontal.
It's a horizontal line, okay? So anytime you have degree 0, you're looking at a horizontal line. All right. No, well, if they're on a flat surface, then it's a straight line. When is a line not straight? When it's drawn on a curve. Kind of like longitudinal, latitudinal lines aren't really lines. Okay, they're curves. All right. So tap, 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 tap. I am not going to use the parent function here. I want you to look at your choices. And I want you to look at, there was 2 of them that had x cubed on it. Okay? And I'm going to pick one specifically. I'm going to pick the one with only 2 terms. Okay? So I would like you to type that one in. Okay? So what was it? Y equals 5x cubed plus, what was it? Oh, I'm sorry, x cubed plus 5x squared. Okay? X cubed plus 5x squared. And I'm picking this one for a reason that I will not tell you right now, but you'll know in a few minutes. Okay? All right, so it kind of looks like, let's go black here. So it kind of came up and it looked like this. Okay? So x cubed plus 5x squared. I'm going to talk a little bit about that in a minute. Now what I want you to do is go back to GeoGebra. And this time, you're going to get a third degree polynomial whose graph crosses the horizontal axis more than once. And you can use what I just wrote, but I want you to modify it just a little bit. I want you to use the same exact numbers. In fact, what I want you to do is I want you to throw a negative in there and change the number in front of the x squared. Okay? So go back to here, close this up, turn that off, make a new one, make a new folder, paste it. So I want you to add a negative somewhere and change the 5. Go for it.
This way.
All right. Melanie, you got it? You got one for me? Give it a shot. Y equals x cubed 4x squared minus 1. See? I said throw a negative in there somewhere. And I like this. A lot of you just didn't change it. So I like this because it didn't just cross 2 times. It crossed 3. By throwing in that minus 1, it shifted the graph down, and that crosses 3 times. Okay? Doesn't have to be this one. Doesn't have to be something else. Most of the rest of you threw a negative in there someplace else. But I made this open-ended. This is going to make grading for me so much fun because normally I'm used to having you guys show me, everybody has to show the same answer. So there's 32 of you in here on any given day. I could have 32 different answers. That's okay. I'm up for the challenge. All right. Questions? Anybody have one they're not sure they got and they want me to take a look at it? Confident? All right. That's what I like to see. All right. Fourth degree. Woo! Okay. And never crosses the horizontal axis. So I think you guys got enough under your belt that you should be able to figure this out on your own now. Okay. Control C. Come back here. Going to turn this off. Close it. Make a new folder. Fourth degree polynomial. Go for it. Okay. So you can just add on something. In the not too distant future, like the next 4 that you're going to be doing, are going to be a little bit more interesting. Okay. Because it's even more open-ended. So before we get to that, I'm going to go back to the last couple. So let's look at this one. All right. So I'm going to turn the other one off. So make sure you can see all the parts. So we're going to look at this one. And, let's just look at this one. Okay. So on my blue one, let's just take a one at a time. On my blue one, how many bumps do I got? 2. Those bumps have names.
Henry.
The bump, Henry and Alfreda. No, not quite. So the bump on the left is what's known as a relative max because it starts increasing and then starts decreasing after the max. So let's define that. Okay. So underneath degree, in that same text box, we're going to put relative max. So not like your Uncle Max.
Oh, he's funny.
I had an Uncle Tony and I had an Uncle Anthony. They were not brothers.
Oh.
They were brother-in-laws. Okay.
Oh, never mind.
Uncle Tony was the gregarious one. He's like, "Hey, how you doing, little T, little Tom? Oh, you doing what in sports?" And Uncle Tony's like, "Hi." Yeah.
So
Uncle Anthony was a little older. Okay. But he's still a nice guy. Brought me to Eagles games. That was fun. All right. Relative max. It's a point on the graph. Here changes from increasing to decreasing. Increasing to decreasing. Okay. And I'm going to add on a little something here. On a defined domain. And I'll talk more about what that means in a minute. That's decreasing on a defined domain. In other words, or instead of defined, let's call it restricted. That sounds so much cooler. Can't go into the restricted domain. Restricted. I cannot type one-handed. Restricted. Okay? Restricted. All right. So I'm going to take this relative max. I'm going to copy and paste and change the max to a min, and we just have to move some stuff around. Okay? So copy, paste, change my max to a min, and instead of going from increasing to decreasing, we're going from decreasing to increasing. So it starts going down and comes back up. So ready? I can do a little cut and paste here. So instead of copy, I'm going to cut from decreasing to increasing. Okay? So what that means is if you take a look at my picture right here, I'm going to go back to my drawing. So an example, let's pick a different color. Green's my favorite, but I don't think it's going to work so good. So let's go blue. So my relative max on this picture right here would be right there. Because you can see from left to right, it's increasing. And then once it hits that point, it starts decreasing. Okay? So that would be a relative max. My relative min would be right here. Because it's decreasing until you get to that point and then increases thereafter. Okay? So that's a relative max and a relative min. And it's on a restricted domain because we're only looking at a piece of it. So the difference between a relative and an absolute would be this. On my parabola, that is the absolute bottom point. The vertex is an absolute minimum or an absolute maximum, depending if it's right side up or upside down. But over here, with my cubic function, you can see that it's not absolute because on the left it keeps going down, on the right it keeps going up. All right, that being said, we're looking for a fourth degree. I'm sorry, we did the fourth degree. So we're going to be looking at the next one. Ooh, bunnies. Not bunnies, but U, N, M, and W. So copy and paste this one. You're not given any restrictions in terms of the type of degree. You just need to make it look like a U, N, M, or W. And it doesn't have to look exactly like these. The N does not have to have all straight lines. In fact, let's make this statement. Let's not make anything a straight line. Okay, so copy. Go back to our over here. We turned everything else off. We closed it up. Go to the bottom. How are we doing time-wise? We are doing okay. Plus sign, folder, paste. So I want you to come up with 4 letters. Put them all in the same spot.
Well, that's easy.
U, N, M, and W. U and N should be pretty easy. We've already done. M and W, we have not. But notice, they look kind of similar. Maybe they could be connected. And the N up here because, we've done them. So y equals x squared is all you need for U. I'm going to turn it off. Y equals x cubed, I don't know, plus 3x squared. There's a nice little N. Okay. Anybody got the M or W yet?
Yeah, I got a really scuffed one.
You got a scuffed one? I don't want a scuffed one. I want a pretty one that's symmetric.
Mine's
Okay, well, let's take a moment. So can we agree that it looks kind of like the fourth degree? Okay, so let's start with fourth degree. Okay. But the problem with just plain old fourth degree is that just climbs up. So we need to make some bumps. Okay, so let's put in some bumps. I don't know. How about plus x cubed? Maybe minus x squared?
Okay, I got it. Let's go.
That cube kind of messes stuff up, right?
Yeah.
So maybe just get rid of the...
I got it.
Look at that. Okay, and if we want to make this a little bit more prominent, I don't know, maybe you could take the coefficient of x squared something other than 1. Look at that. Okay, so there's your W. Take a minute, just a minute. You should be able to figure out an M like that.
Oh, because we get
Because if we just change the 1, hey, I don't want to retype this. Anybody remember how to do it? Go here, duplicate it. Okay, click done. You might want to give it a different color, unless maybe, I don't know, maybe you want to keep it green. So if I just make this negative, that doesn't quite cut it, does it? So I'm going to change that to a negative and change the other one to a positive. Okay. I got my M and my N. Excellent. Save it. Close it. Turn it off. Let's go back here. And hey, we're done. So in 5 minutes, let's see if you can get it done. And if you can't, that's okay. You can go back in here. Ooh, there's a cooldown. There's 2 problems. It's a Cami doc. So open that up. Come on now. Oh, that's so cool. It is not what I want to see at all. Is that what yours looks like?
Yeah.
All right, let me fix it.
Go down.
Open up with Cami, and the Cami doc should be okay. That was weird. Okay, so let me make this clear. Whoopsies. The first question. See, it's question 1. It does not have 3 parts. It has 3 characteristics. You're going to write one single equation that's both degree 5, has 4 terms, and crosses at y equals 12. For number 2, you're going to approximate, the input values. That is code for what letter? You have 2 choices, x or y. X. So you have to find the x values for your relative max and minimums. Okay? So see what you can get done in the next 4 minutes. Whatever you don't finish, we'll look at on Tuesday because we're going to do ACT prep on Monday.
What's
Nice.
ACT?
ACT is not till
Okay.
April. Okay.
Alright.